The water you drank this morning might have lapped at the shores of ancient Rome. It could have tumbled over Victoria Falls 1,000 years ago, or carried a Viking longship out to sea. The planet's water is on a constant, epic journey, and its most visible pathways are the rivers. We think we know them, we see them from bridges, we fish in them, we watch them on maps.
But they are so much more than simple lines of blue. They are the Earth's veins, and we're about to follow them on an unseen journey to uncover 100 of their most astounding truths. Let's start with a sense of scale, because it's almost impossible to comprehend. If you were to take every single river, stream, and creek on Earth and lay them end to end, you would create a single, continuous waterway stretching for more than 23 million miles. That's a line of water long enough to wrap around the Earth's equator over 900 times. It's a distance so vast, it could take you to the moon and back almost 50 times. This immense network is the planet's circulatory system, carrying not just water, but life, nutrients, and the very sediment that builds our world, constantly carving and reshaping the continents in a process that never, ever stops. It's a global superhighway of water, flowing all at once, every second of every day. And where does this colossal journey begin? We have this image of a river's source, its headwaters, as a pristine mountain spring bubbling up from the ground. While that's sometimes true, the birth of a river is often far less dramatic and far more fascinating. A river's true source can be an unremarkable, boggy marsh, a slowly melting glacier dripping water into a high-altitude lake, or even just a damp patch of ground where enough rainwater collects to form a tiny, persistent trickle. In fact, for many of the world's great rivers, like the Amazon or the Nile, the exact location of the primary source is still a subject of fierce debate among geographers and explorers, with teams launching expeditions to this day to find that one definitive starting point in a complex web of countless tiny tributaries. This ambiguity about a river's beginning hints at an even stranger secret. There is no single, universally accepted scientific definition of what a river actually is. We all know one when we see one, but the line that separates a large stream from a small river is completely arbitrary. Is it width, depth, the volume of water it carries, known as its discharge? Or is it the permanence of its flow? Different countries and even different organizations use their own criteria. In the United Kingdom, a watercourse might be called a beck, bourne, or brook, while in the United States, it could be a creek, run, or kill. What one map labels a river, another might call a stream. It's a fundamental feature of our planet that we've never quite managed to pin down with a single, tidy label. And if defining the rivers we can see is that tricky, imagine the ones we can't. Because flowing right beneath our feet is a hidden world of subterranean rivers. These aren't just small trickles in caves. They are massive, powerful watercourses that have carved out immense underground networks through soluble rock, like limestone. The Sac Actun cave system in Mexico's Yucatan Peninsula is home to the world's longest known underground river, stretching for over 200 miles through a breathtaking labyrinth of submerged tunnels and caverns. These sunless rivers have their own unique ecosystems, with strange, pale creatures that have evolved in total darkness. They are phantom waterways, moving vast quantities of water completely out of sight. Their paths often a complete mystery until a sinkhole or cenote opens a sudden, stunning window into their dark, flowing world. But the unseen rivers don't stop there. They also exist high above our heads. Meteorologists have discovered what they call atmospheric rivers, which are long, narrow corridors of concentrated water vapor flowing through the sky. These rivers in the atmosphere can be thousands of miles long, but only a few hundred miles wide, and they carry an unbelievable amount of moisture. A strong atmospheric river can transport a volume of water vapor equivalent to more than 25 times the average flow of the Mississippi River at its mouth. When these celestial rivers make landfall, particularly against mountain ranges, they release all that water as immense amounts of rain or snow, making them responsible for both life-giving water supplies and some of the most extreme flooding events on the planet. From the sky back down to the ground, the color of a river tells a profound story about its journey. A river's color is its biography, written in water. The famous Yellow River in China gets its distinct color from carrying enormous quantities of fine, yellowish silt called loess, picked up from the landscape it flows through. In the Canadian Rockies, rivers like the Bow River are a stunning, opaque turquoise because they are fed by glaciers that grind rocks into a fine powder known as glacial flour, which stays suspended in the water and reflects sunlight in just the right way. And then there are blackwater rivers like the Rio Negro, a major tributary of the Amazon. Its dark, tea-colored hue comes not from pollution or mud, but from tannins leached from the decaying leaves of the dense rainforest floor, creating a clear yet deeply stained acidic water that supports a completely different array of life than its muddy neighbors. This ability to carry sediment and carve through landscapes reveals perhaps the most mind-bending fact of all: a river can be older than the mountains it flows through. This sounds impossible, like water flowing uphill, but it's a geological phenomenon known as antecedence. If a river has been flowing along a certain path for millions of years, and the land underneath it begins to slowly uplift to form a mountain range, the river can sometimes cut down through the rock as fast as the mountains rise. It holds its original course, carving a deep gorge or canyon directly through the new mountain chain. The New River, which flows through the Appalachian Mountains in the United States, is a classic example. It's considered by many geologists to be one of the oldest rivers in North America, and possibly the world, relentlessly sawing its way through ancient rock for hundreds of millions of years, a timeless force that refused to be moved. What if I told you the river you're picturing in your head right now doesn't really exist? At least not in the way you think. We see a ribbon of water, but that's like looking at a single vein and trying to understand the entire circulatory system. The reality of what makes a river is so much grander, stranger, and more complex than a simple line on a map. Let's peel back the surface and redefine what we're really looking at. 5. We can start with the most basic question. What's the difference between a river, a stream, a creek, and a brook? The surprising answer is, there isn't one, not a scientific one anyway. While we might imagine a river as being larger than a stream, there is no universally accepted hydrogeological rule that says when a flowing body of water graduates from one name to the next. These labels are almost entirely based on local tradition and historical naming conventions. The Saw-Kill in New York is officially a kill, a Dutch word for creek, yet it's larger than many channels that locals proudly call rivers. Conversely, the Roe River in Montana was once in the Guinness World Records as the world's shortest river at just 201 feet, a distance you could walk in under a minute. It's a powerful reminder that our human language often struggles to neatly categorize the raw, fluid forces of nature. So a river is a river simply because, at some point, enough people decided to call it one. But if the name is subjective, what isn't? The answer is a river's domain, its watershed. This is where the definition gets truly massive. A river isn't just the water in its channel. It is the ultimate destination for every single drop of rain, every snowflake, every trickle of groundwater across a vast expanse of land called a drainage basin. Think about the Amazon River. The water you see flowing into the Atlantic Ocean didn't just come from the river channel itself. It came from the slopes of the Andes Mountains, from the canopy of rainforests in 9 different countries, from an area of over 7 million square kilometers. Every time it rains anywhere in that immense basin, that water is on a journey, pulled by gravity through soil, downstreams, and into tributaries, all destined to unite in the Amazon's main stem. So, a river isn't just a line, it's the drain for an entire landscape, a continent-sized funnel of which the flowing water is only the final, visible spout. And all that water, gathered from such a huge area, doesn't just travel in a straight line. It goes on an epic journey, and like a character in a story, it changes its personality completely along the way. Geographers split a river's life into 3 distinct stages. The upper course, near the source, is the river's youth. It's steep, fast, and energetic, crashing through mountains and carving out sharp, V-shaped valleys and waterfalls. Next is the middle course, its adulthood. Here, the land flattens, the river slows down, and it begins to meander, swinging back and forth in wide loops, eroding the outer banks and depositing sediment on the inner ones. Finally, there's the lower course, its old age. Close to the sea, the river is wide, slow, and heavy with sediment. The landscape is almost completely flat, and the river often deposits its sediment to form vast, fertile floodplains and deltas. So when you see a river, you're only seeing one chapter of its life story, a single snapshot of a dynamic process of creation and destruction that stretches for hundreds or even thousands of miles. 8. As a river carves these different paths, it creates a very specific home for itself. And to truly understand it, we need to know its anatomy. We have the riverbed, which is the bottom of the channel. Then we have the banks, the sides of the channel that contain the flow during normal conditions. But there's a third, crucial part that many people don't realize is an integral piece of the river system, the floodplain. This is the wide, flat area of land on either side of the banks. Most of the time, it's dry land, but it was built by the river over millennia, through countless floods that deposited layers of rich silt. Hydrologists even have a term called the bankful stage, which is the point where the water level is right at the top of the banks, just about to spill over. Once it crosses that threshold, the river is simply reclaiming its wider, ancient home. The floodplain isn't just land next to a river. In a very real sense, it is the river, just waiting for the right conditions to be filled. But what about rivers that have no banks you can see? Rivers that flow in complete darkness, hidden from the world above. These are subterranean rivers, and they completely shatter our surface-level definition. These are not just small trickles in caves, they can be massive, powerful systems. The Yucatan Peninsula in Mexico, for instance, has almost no surface rivers at all. Instead, rainwater seeps through the porous limestone bedrock, forming an enormous underground network of flowing water. The famous cenotes, those stunning natural sinkholes, are actually windows into these hidden rivers, places where the roof of the underground cave system has collapsed. The Sistema Sac Actun is a submerged cave system there that stretches for over 220 miles, making it one of the longest underwater rivers in the world. These subterranean flows prove that a river's definition can't be limited to what we can see. It's any significant, natural channel of water flowing from a higher to a lower elevation, whether it's under sunlight or under 1,000 tons of rock. 10. From rivers that are always hidden to rivers that are only sometimes there. It sounds like a riddle, but for vast parts of our planet, it's the norm. These are known as ephemeral rivers, and they only flow for a brief period after rainfall. In arid and desert regions, a riverbed can lie dry for months or even years, a dusty scar on the landscape. It might look like a fossil, a relic of a wetter time. But after a heavy downpour, these channels can roar to life with startling speed, transforming into a raging torrent in a matter of minutes. Australia's Todd River is a famous example. It runs through the desert town of Alice Springs and is dry for most of the year. It's so reliably empty that the town hosts a boat race in the dry riverbed, where teams run along carrying bottomless boats. Yet, every few years, a massive storm in the surrounding hills will send a wall of water surging down the channel, reminding everyone that its identity as a river was never lost, only dormant. 11. So, a river can be temporary, but can it also be undecided? Instead of carving one single clear path, some rivers choose a different strategy. Welcome to the world of braided rivers. These incredible natural phenomena occur where a river carries a huge amount of coarse sediment, like gravel and sand. When the river's flow slows down, it can't carry this heavy load anymore, so it dumps it in the middle of its own channel. These deposits form small, temporary islands or bars, which force the water to split and flow around them. This process repeats over and over, creating a stunning and complex network of constantly shifting, interweaving channels that look like a braid of hair from above. You often find them in mountainous regions near glaciers, where the ice grinds up rock into sediment and meltwater provides the flow. The Rakaia River in New Zealand is a spectacular example, a shimmering, miles-wide tapestry of water and gravel that is constantly remaking itself. It's the ultimate proof that a river isn't a fixed thing, but a living, breathing system that is always negotiating its path with the land it flows through. What if I told you the longest river in the world, the one you learned about in school, might be the wrong one? For generations, every textbook and quiz show has given the same answer. But in the world of geography, some records are written in shifting sand, not stone. We're about to journey to the titans of the water world, the rivers that hold the records for being the longest, widest, deepest, and most powerful on Earth. This brings us to our 15th amazing fact. The heavyweight title for the world's longest river is still fiercely contested. For centuries, the Nile River in Africa held the undisputed crown, stretching an incredible 6,650 kilometers. Its source was a mystery for ages, a puzzle that obsessed explorers. But in the 21st century, a new contender emerged from the dense rainforests of South America. Using advanced GPS technology, scientists traced the Amazon River to a new, more distant source high in the Peruvian Andes, a glacial stream called the Mantaro River. This recalculation potentially pushes the Amazon's total length to over 6,992 kilometers, officially dethroning the Nile. The debate rages on because measuring a river is incredibly tricky. Do you measure the longest continuous channel? What about seasonal changes? The very definition of a river's source is a point of scientific argument, making this a geographical detective story that's still unfolding. While the battle for length continues, there is no argument whatsoever about which river is the most powerful. And for fact number 16, we stay with the mighty Amazon, which is, without a doubt, the largest river in the world by water volume. It's not just a record holder, it's in a league of its own. The Amazon discharges an average of 209,000 cubic meters of water into the Atlantic Ocean every second. To put that into perspective, that's more than the next 7 largest rivers combined. During its wet season, this flow can be so immense that it pushes a massive lens of fresh water more than 150 kilometers out into the salty Atlantic. Sailors far from the coast have reported being able to drink fresh water straight from the ocean. This colossal outflow accounts for nearly 20% of all the fresh water that flows from all the world's rivers into the oceans. It's less a river and more a moving ocean itself. From the sheer force of its current, we travel south to a river so wide it completely shatters our perception of what a river should look like. Fact 17 introduces us to the Rio de la Plata, or the River Plate, on the coast of South America. At its mouth, where it meets the Atlantic between Argentina and Uruguay, this river is a staggering 220 kilometers wide. Let that sink in. Standing on the shore in Buenos Aires, you cannot see the opposite bank in Uruguay. The horizon is just water, as if you were looking out at a vast sea. This incredible breadth is why it's often called an estuary, a transitional zone between river and ocean. But it's fed by the Paraná and Uruguay rivers, carrying immense volumes of sediment that give the water its distinct brownish color. It's a true giant, a river that has become an inland sea, erasing the line between land and the open ocean. But rivers don't just expand outwards. Some carve their way down, deep into the Earth's crust, creating chasms hidden beneath the surface. For our 18th fact, we journey to the heart of Africa to find the world's deepest river, the Congo. While its surface churns with powerful rapids, its true secret lies below. In its lower reaches, the Congo River plummets to depths of over 220 meters, or 720 feet. That's deep enough to submerge the Golden Gate Bridge's towers. This section is essentially a submarine canyon, a deep, narrow gorge carved into the continental shelf. The pressure at these depths is immense, and the sunlight cannot penetrate, creating a unique and isolated ecosystem. Scientists believe that different species of fish have evolved in these deep, dark pools, completely separated from their relatives in the shallower parts of the river. It's a hidden world of extremes, a vertical abyss flowing silently beneath the jungle. We've been talking about giants, the longest, the biggest, the widest, the deepest. But what about the other end of the scale? Fact number 19 proves that a river doesn't have to be massive to be a record breaker. For this, we look at the world's shortest river. For years, this title was held by the Dee River in Oregon, which flows a mere 37 meters. But it was eventually challenged and defeated by the Roe River in Montana. Flowing from a giant spring to the Missouri River, the Roe's full length, on a good day, is just 61 meters, or 201 feet. The feud between the two towns over the Guinness World Record became a fun, lighthearted rivalry. The Roe River is so short that its entire course, from source to mouth, can be walked in less than a minute. It's a perfect miniature hydraulic system, a tiny but complete river that stands in stark contrast to the continental behemoths we've seen. From the shortest straight line, we now turn to the most complicated path imaginable. Some rivers meander, but our 20th fact introduces a river that takes meandering to an almost absurd extreme. Deep in the Guerrero state of Mexico flows the Omiltemi River, which holds the record for being the world's most sinuous. Sinuosity is a measure of how much a river twists and turns compared to a straight line. A perfectly straight river has a sinuosity of 1. The Omiltemi River has an incredible sinuosity index of 4.25 over a significant portion of its length. This means that to cover a straight line distance of just 1 kilometer, the river water has to travel a winding, looping path of 4¼ kilometers. It's a liquid labyrinth, a geographical doodle carved into the landscape, constantly folding back on itself in an endless series of tight, looping bends. But perhaps the most impressive record isn't about a river's length or depth, but about what it builds at its end. For our 21st and final fact in this chapter, we arrive at the largest river delta on the planet, the Ganges-Brahmaputra Delta. Also known as the Bengal Delta, this colossal formation in South Asia is created by the confluence of several river systems, primarily the Ganges and Brahmaputra, as they empty into the Bay of Bengal. It covers an area of over 100,000 square kilometers, roughly the size of Iceland. This is not just a geographical feature. It's one of the most fertile and densely populated regions on Earth, home to over 130 million people. The delta is also home to the Sundarbans, the world's largest mangrove forest and a critical habitat for the endangered Bengal tiger. It's a monumental testament to the power of rivers to not just carve the land, but to create it, building new worlds, grain by grain, at the edge of the sea. Imagine standing on a coastline, staring out at what looks for all the world like an ocean. The water stretches to the horizon, waves lap at the shore, and the air smells of salt and sea. But what if you weren't standing on a coast at all? What if you were actually standing on the bank of a river so colossal, so utterly immense, that it shatters our very definition of the word? We often think we have a handle on what a river is, a ribbon of water snaking through the land. But the true scale of these systems is a secret hidden in plain sight, a story told in impossible widths and terrifying unseen depths. We've explored their beginnings and their journeys, but now we plunge into a dimension that defies belief, where rivers mimic oceans and flow invisibly beneath our feet. Let's travel to the coast of South America, to a place where Argentina and Uruguay meet the Atlantic. Here you'll find what appears to be a massive bay or gulf, a vast expanse of brownish water. This is the Rio de la Plata, and it holds a stunning title. It is, by a wide margin, the widest river in the world. At its mouth, where it finally surrenders to the ocean, this river is a staggering 220 kilometers, or 140 miles wide. That's wider than the entire length of some countries. From one bank, the opposite shore is completely invisible, lost beyond the curvature of the earth. It's so vast that early European explorers were convinced they had found a sea, not a river's end. In fact, it's technically a funnel-shaped estuary formed by the confluence of the Uruguay and Paraná rivers, but its freshwater flow and riverine characteristics have cemented its status. Because of its sheer scale and the mixing of fresh and salt water, geographers often refer to the Rio de la Plata as a marginal sea, a body of water that is part river, part ocean, and entirely mind-boggling. It drains a hydrological basin that covers about a fifth of the entire South American continent, a testament to the colossal power of the river systems that feed it. It's a place where the rules of geography seem to bend, but a river doesn't need to be an estuary masquerading as an ocean to display shocking width. Some rivers perform an incredible magic trick every single year, transforming from merely massive to continent-spanning water worlds. And for that, of course, we return to the king, the Amazon. During the dry season, the main channel of the Amazon River is already immense, ranging from about 4 to 11 kilometers, or 2 to 6 miles, across. That's already wider than many famous rivers are long. But when the rainy season arrives, the Amazon doesn't just rise, it explodes. The river swells so dramatically that it spills over its banks and floods the surrounding rainforest, creating a seasonal floodplain known as the Várzea. During the peak of the wet season, the Amazon River system can expand to an unbelievable width of 40 kilometers, or 25 miles, and in some places, even wider. This isn't just a river anymore. It's a vast, slow-moving inland sea, dotted with the treetops of a submerged forest. This annual inundation is the lifeblood of the region, depositing nutrient-rich silt that fertilizes the land and creating one of the most unique and biodiverse ecosystems on the planet, where fish swim among tree trunks and entire communities adapt their lives to the rhythm of the rising and falling water. It's a breathtaking display of how a river's identity isn't fixed, but is a dynamic, breathing entity whose scale can change on a truly continental level. While these incredible widths are on full display, a river's most dramatic secrets are often hidden far below the surface, in depths that are just as, if not more, astonishing. Forget what you think you know about deep water. Deep in the heart of Africa flows the Congo River. the second largest river in the world by discharge volume, second only to the Amazon. But the Congo holds a record the Amazon can't touch. It is, unequivocally, the deepest river on Earth. While many major rivers might reach depths of 30 or 40 meters, or around 100 feet, the Congo River plunges to terrifying, unlit extremes. In its lower reaches, the river has been measured at depths of over 220 meters, or 720 feet. That's deep enough to completely submerge the Washington Monument with room to spare. This incredible depth isn't a fluke. It's the result of the river carving a gigantic canyon through the landscape, a canyon that is now drowned beneath its own powerful flow. The water here moves with incredible force, creating a series of rapids and cataracts known as the Livingston Falls. The sheer volume and velocity of the water, constrained by the narrow canyon, has scoured the riverbed to these astonishing depths. This extreme environment creates a unique ecological niche, with fish species that have adapted to live in the crushing pressure and total darkness of the river's abyss, completely isolated from those in the upper waters. It's a hidden Grand Canyon, flooded and thundering with more water than any other river in Africa. But what if a river wasn't just deep? What if it was so deep it was actually at the bottom of the sea? The line between land and ocean continues to blur when we discover that the concept of a river isn't limited to dry land. Believe it or not, there are rivers that flow along the bottom of our oceans. One of the most spectacular examples was discovered flowing along the seabed of the Black Sea. This isn't just a slow-moving current, it's a genuine, channel-bound river of water. How is this possible? It's all about density. The river is made of extremely salty water from the Mediterranean Sea, which flows into the Black Sea through the Bosphorus Strait. This Mediterranean water is much denser and saltier than the surface water of the Black Sea, so it sinks directly to the bottom. Once there, it begins to flow along the seafloor, carving out its own distinct channel with banks, levees, and even rapids and waterfalls, just like a terrestrial river. This Black Sea submarine channel is immense, estimated to be about 35 meters, or 115 feet, deep and a kilometer, or 0.6 miles, wide in places. If it were on land, it would be the sixth largest river in the world by discharge. It carries nutrient-rich sediment for miles across the abyssal plain, creating a unique ecosystem on the dark seafloor. It's a ghostly echo of a terrestrial river, a hidden world that proves the fundamental physics of flowing water can create rivers in the most unexpected places imaginable. From a river under the sea, we now go to a river under another river. But beneath the world's greatest river flows its secret, subterranean twin. The Amazon River is a spectacle of nature, but miles below its muddy waters and deep into the Earth's crust, scientists believe another river flows in parallel. Named the Hamza River, after the head of the research team that discovered it, this is a subterranean river of epic proportions. It isn't a river in the conventional sense, with open channels and fast-moving water. Instead, the Hamza is a geologically defined river where groundwater flows incredibly slowly. We're talking mere meters per year, west to east through porous sedimentary rock nearly 4 kilometers or 2.5 miles beneath the surface. While its flow rate is glacial, its scale is astounding. It's estimated to be of a comparable length to the Amazon, over 6,000 kilometers long, but potentially hundreds of kilometers wide. Its estimated flow rate is enormous, though still only a fraction of the Amazon's. The discovery was made by analyzing temperature variations in 241 inactive oil wells drilled in the Amazon basin decades ago, which revealed the telltale signature of slow-moving deep water. The Hamza represents an entirely different kind of river system, a vast, invisible drainage network that is an integral, yet unseen, part of the Amazon basin's hydrology. It's a ghost river, flowing in utter darkness miles below the jungle floor. Measuring an invisible river under the ground, or a channel at the bottom of the sea, might sound like impossible tasks. And even measuring the depth of a turbulent giant like the Congo requires far more than just a long piece of string. So how do we actually map these hidden dimensions?
The science of measuring the depth of water bodies is called bathymetry, and it's a field that has evolved dramatically. For centuries, the only method was sounding, which literally involved dropping a weighted line overboard and measuring how much rope went out before it hit the bottom. This was slow, painstaking, and only gave you the depth of a single point.
Today, the workhorse of bathymetry is sonar, specifically multi-beam echo sounders. A device on a ship sends out a fan-shaped pulse of sound waves towards the riverbed. By measuring the precise time it takes for these sound waves to bounce off the bottom and return to the ship, computers can calculate the depth across a wide swath of the riverbed with incredible accuracy. This process creates detailed three-dimensional maps of the river floor, revealing canyons, ridges, and channels that were previously invisible. For even larger scales or inaccessible areas, scientists are now using satellite altimetry, which can measure tiny variations in the water's surface height caused by the gravitational pull of underwater features, like mountains and canyons, allowing them to infer the shape of the riverbed or seabed from space. It's this sophisticated technology that allows us to uncover the true, staggering scale of these hidden aquatic worlds. So we have rivers wider than countries and deeper than skyscrapers. We have rivers under the sea and rivers under the ground. But all this exploration of extremes reveals a final, fascinating truth about the very shape of rivers themselves. When you picture a river, you probably imagine something much wider than it is deep, and for the most part, you'd be right. Most of the world's great rivers, like the Amazon, the Nile, and the Mississippi, have a very high width-to-depth ratio. The Mississippi, for example, can be over a mile wide, but averages only about 30 to 40 feet deep. This wide, shallow profile is typical for rivers flowing through broad, flat floodplains made of soft sediment that is easily eroded sideways. However, as we saw with the Congo, this is not a universal rule. Rivers that are forced through narrow, steep gorges cut into hard bedrock cannot easily expand sideways. All of their immense erosive power is focused downwards, scouring the channel deeper and deeper. This results in a low width-to-depth ratio, creating deep, narrow, and incredibly powerful rivers. So, the shape of a river, its fundamental dimensions of width and depth, is a direct reflection of its life story. It tells you about the landscape it flows through, the power it wields, and the geological constraints it has battled against for millennia. The simple ratio of how wide it is versus how deep it is tells a complex story of power, geology, and time. And it's a story that continues, as we'll see, in the incredible things these rivers carry with them on their journey to the sea. What if I told you that the river you see, the shimmering surface, the flowing current, is only half the story? That beneath the mud, sand, and stone of the very riverbed itself, there's another, hidden river flowing in darkness. It's a concept that completely changes our understanding of what a river is. Because deep under the visible channel, there exists a secret world known as the hyporheic zone. This isn't a separate river of water, but a layer of sediment, sometimes stretching for miles on either side of the riverbanks and deep underground, where river water and groundwater slowly mix. It acts as the river's living, breathing lung and liver all in one. This subterranean ecosystem is teeming with microscopic life, bacteria, fungi, and tiny invertebrates that form the foundation of the river's health. They diligently filter pollutants, process nutrients and even regulate the river's temperature, creating a buffer that protects the entire aquatic environment from drastic changes. So, the next time you see a river, remember that its true heart is beating silently right under your feet. But the hidden world isn't just microscopic. Some of the river's inhabitants wield powers that seem straight out of a comic book. In the murky waters of the Amazon and Orinoco basins, you'll find a creature that has mastered one of nature's most potent forces, electricity. Meet the electric eel. And the first surprising fact about it is that it's not an eel at all. It's actually a type of knife fish, more closely related to carp and catfish. But its name comes from its truly shocking ability. Specialized cells, called electrocytes, evolved from muscle tissue, are stacked like batteries in 3 pairs of abdominal organs that make up nearly 80% of its body. When it unleashes a high-voltage discharge, it can generate up to 860 volts, 5 times the power of a standard US wall socket, which is more than enough to stun a horse. They also use lower voltage pulses as a kind of biological radar, creating an electric field around themselves to navigate the dark waters and hunt for prey without ever needing to see it. And if a creature that can generate its own lightning isn't impressive enough, some riverbeds hide giants that have been lurking there since the time of the dinosaurs. We're talking about one of the largest and heaviest freshwater fish on the planet, the giant freshwater stingray. Found in the rivers of Southeast Asia, particularly the Mekong, this creature is a true behemoth. It can grow up to 16 feet from snout to tail and weigh a staggering 1,300 pounds. Imagine a living, breathing dinner table gliding along the river bottom. For most of its life, it remains perfectly camouflaged, buried in the sand and mud, using special sensors around its mouth to detect the electrical fields of prey, like clams and crabs hiding nearby. And while they are generally docile, they possess a formidable defense, a serrated, venomous barb at the base of their tail that can be nearly 15 inches long and can easily pierce through human bone. But size isn't everything in the river's hidden ecosystem. Sometimes the most feared creature is also one of the smallest. Let's head back to the Amazon for a fish that has earned a truly terrifying reputation. It's the candaroo, often called the vampire fish of Brazil. This tiny, translucent catfish is parasitic, and its primary method of feeding is what makes it so notorious. It's hematophagous, meaning it feeds on blood. Typically, it will seek out a larger fish, swim into its gill passages, and erect a short, sharp spine to lodge itself in place. It then gnaws a hole into an artery and feasts on the blood that flows out. Its chilling reputation among humans, however, comes from legendary tales of it swimming up the urethra of unsuspecting bathers. While documented cases are incredibly rare and debated by scientists, the sheer possibility has made this tiny predator one of the most feared creatures in the entire Amazon basin. Thankfully, not every Amazonian resident is so terrifying. The river's murky depths are also home to some of the most intelligent and bizarrely adapted mammals on the planet. Floating through the flooded forests are the world's river dolphins. Unlike their sleek, gray ocean cousins, these freshwater cetaceans are a marvel of specialized evolution. The Amazon river dolphin, known as the boto, can be a shocking shade of pink. But its most unique feature is its unfused neck vertebrae. This allows it to turn its head a full 90 degrees, an essential skill for navigating the complex maze of submerged trees during the rainy season. Living in water that is often as opaque as coffee, its eyesight is greatly reduced. Instead, it relies on one of the most sophisticated sonar systems in the animal kingdom, using echolocation to paint a detailed picture of its underwater world, a skill it has perfected far beyond most of its marine relatives. But intelligence and adaptation aren't just for the big guys. Down on the riverbed, some of the most ingenious architects in the animal kingdom are hard at work. If you were to look closely at the pebbles on the bottom of a clean, fast-flowing stream, you might find that some of them start to move. You'd be looking at the incredible work of the caddisfly larva. Before it transforms into a winged insect, this tiny creature spends its life underwater. And to protect its soft body, it builds its own mobile home. Using silk spun from a gland in its head, it meticulously glues together materials from its environment. Some species use grains of sand to create perfect spiraling tubes. Others use tiny twigs chopped to precise lengths. Still others use hollowed-out reeds or even the discarded shells of tiny snails. The result is a beautiful, custom-built suit of armor that is both a fortress and a masterful piece of camouflage. While some creatures build their own armor, others are born with it. Lurking in the slow-moving rivers and bayous of North America is a living fossil, a predator that has patrolled these waters virtually unchanged for 100 million years. This is the alligator gar. With its broad, alligator-like snout packed with 2 rows of needle-sharp teeth, it's an intimidating sight. But its true defense lies in its scales. It's covered in an interlocking armor of diamond-shaped, bony scales coated with a substance similar to tooth enamel, making them nearly impenetrable. This natural armor was so effective that Native American tribes used the scales as arrowheads. Even more remarkably, the alligator gar is a bimodal breather. It has gills to breathe underwater like any other fish, but it also has a specialized swim bladder connected to its throat that works like a primitive lung, allowing it to gulp air from the surface and survive in stagnant, oxygen-poor water where other fish would perish. We've explored hidden worlds beneath the riverbed, shocking creatures, and ancient predators. But what if I told you the strangest secret of all is that sometimes a river can flow right through another body of water, completely unseen? This isn't a myth. It's a mind-bending reality in places like Mexico's Yucatan Peninsula. In deep, water-filled sinkholes called cenotes, a bizarre phenomenon can occur. A layer of fresh, clear rainwater sits on top of a deeper layer of salt water that has seeped in from the ocean. Where these 2 layers meet, there's a blurry, shimmering boundary called a halocline. And in Cenote Angelita, decaying jungle debris has settled on this halocline, creating a thick cloud of hydrogen sulfide. For divers descending through the fresh water, it looks exactly like they are emerging from the clouds to see a river flowing 30 meters below them, complete with tree branches and misty banks. It's a river within a river, a ghostly, surreal landscape, proving that beneath the surface, the secrets of the water are more magical and mysterious than we could ever imagine. Imagine standing on the bank of a river, watching the water flow steadily towards the sea. Now imagine it stops, turns around, and starts flowing backward, uphill. It sounds like something from a fantasy novel, but on our planet, rivers break the rules all the time. They are not just passive channels of water. They are dynamic, chaotic forces that can change their minds, disappear without a trace, and even steal from one another in acts of geological piracy. We've seen how rivers carve canyons and build civilizations, but some of the most fascinating stories are about the ones that defy expectations. Let's journey to a place where a river decides its journey is over long before it ever sees an ocean. In the heart of southern Africa lies a river that performs a spectacular disappearing act every single year. This leads us to our 38th incredible fact. The Okavango River in Botswana never reaches the sea. Instead of flowing into an ocean, It spills out onto the open sands of the Kalahari Desert, creating the Okavango Delta, a massive, stunningly vibrant inland wetland. It's one of the very few major inland delta systems that doesn't flow into a sea or ocean. For 6 months of the year, the river swells with rains from the Angolan highlands and pushes 11 cubic kilometers of water into the desert, transforming over 15,000 square kilometers of arid sand into a lush maze of lagoons, channels, and islands. River that never finds the sea becomes a critical oasis, supporting an astonishing concentration of wildlife, from elephants and hippos to some of the world's most endangered predators. Then, as the dry season returns, the delta shrinks, the water absorbed by plants, evaporated by the sun, or transpired into the atmosphere. The river essentially sacrifices itself to the desert, creating a paradise in one of the most unlikely places on Earth. The Okavango makes a definitive choice to end its journey in the desert. But what about a river that can't decide where it wants to go at all? In Wyoming's Teton Wilderness, there's a place so perfectly balanced on the backbone of America that a single stream does the unthinkable. This brings us to fact number 39. At a spot called Parting of the Waters, a creek literally splits into two, with one half flowing to the Atlantic Ocean and the other half flowing to the Pacific. This isn't just a fork in the road, it's a fork in the continent. The stream, North Two Ocean Creek, flows down from a plateau and hits a peculiar, saddle-shaped rock formation right on the continental divide. Here, the water divides. The western fork, named Pacific Creek, travels over 1,300 miles to join the Snake River, then the Columbia River, before finally emptying into the Pacific Ocean. The eastern fork, Atlantic Creek, embarks on an even longer journey of over 3,400 miles, joining the Yellowstone River, then the Missouri, then the Mississippi, before its waters ultimately merge with the Atlantic Ocean in the Gulf of Mexico. It is one of the only places on the planet where a fish could, theoretically, swim from the Pacific watershed into the Atlantic watershed. It's a quiet, unassuming spot in the wilderness that represents a moment of profound geographical indecision, where a river literally sends its waters to opposite ends of the world. A river splitting its path is strange enough, but nature can be far more aggressive. Sometimes one river will actually steal the water of another in a dramatic process known as river piracy. And that's our 40th amazing fact. River piracy, or stream capture, occurs when a river from one watershed erodes its way into the channel of a river in an adjacent watershed and captures its flow. Imagine two rivers flowing side by side in separate valleys, divided by a ridge. If one river has a steeper gradient, it will have more erosional power. It will carve into the landscape more aggressively, cutting backward into its headwaters. Over thousands of years, it can chew right through the dividing ridge and intersect the channel of its neighbor. The moment it breaks through, the water from the weaker or beheaded river is diverted into the channel of the stronger pirate river. Suddenly, the downstream portion of the beheaded river is left high and dry, or as a dramatically smaller stream. One of the most monumental cases of river piracy in history created the river we now know as the Ohio. For millions of years, a massive river called the Taze flowed from the Appalachians northwest across Ohio, Indiana, and Illinois. But during the Ice Ages, advancing glaciers blocked its path, creating vast lakes. Water spilling over the southern ridges from these lakes carved a new, much steeper path to the Mississippi. This new channel, the modern Ohio River, captured the headwaters of the Taze and numerous other rivers, completely redrawing the map of water in North America. This idea of a river changing allegiance isn't always so violent. Sometimes it's just plain confusing. A river that seems to work for two different teams at once. In the dense rainforests of Venezuela, there is a river that defies the very definition of a watershed. This is fact number 41. The Casasiquiare River is a massive natural canal that connects two of the world's greatest river systems, the Orinoco and the Amazon. It's a bifurcation, a distributor that splits from one river and flows into a completely separate one. The Casasiquiare branches off from the upper Orinoco River, then flows for about 220 miles southwest through the jungle before joining the Rio Negro, which is the largest tributary of the Amazon River. This means water and the aquatic life within it can pass freely between these two colossal, otherwise distinct river basins. It's as if a major artery in your body decided to connect directly to someone else's. For centuries, European explorers debated whether it was even real. Its existence was only confirmed in the early 1800s by the legendary naturalist Alexander von Humboldt after a grueling expedition. The Casasiquiare is by far the largest and most famous example of a river bifurcation on the planet, a permanent, powerful link that blurs the lines between two continental-scale ecosystems. So far, we've seen rivers that stop, split, and steal. But some rivers have a behavior that is even more mind-bending. They flow backward. In certain rivers around the world, a phenomenon called a tidal bore causes a powerful wave to travel upstream against the river's natural current. A tidal bore occurs in coastal areas with a large tidal range, a big difference between high and low tide, and where the incoming tide is funneled into a narrow, shallow river or estuary. As the tide rushes in, the leading edge of the water forms a distinct wave or series of waves that surges up the river. Some of these are gentle ripples, but others are forces of nature. The most famous was the Pororoca on the Amazon River, which could produce waves up to 13 feet high that traveled hundreds of miles inland at over 15 miles per hour, though dam construction has greatly diminished its power. One of the most predictable and accessible is the Severn Bore in the United Kingdom, which attracts surfers who try to ride the wave for miles as it pushes its way upstream. This backward-flowing wave is a temporary but powerful reminder that even the relentless one-way flow of a river is no match for the gravitational pull of the moon. From a river that flows backward, we go to our final and perhaps strangest behavior of all, a river that vanishes completely. Our 43rd fact is that vast subterranean river systems exist, flowing through enormous caves and tunnels deep beneath the Earth's surface, sometimes disappearing from the light for hundreds of miles. This often happens in what's known as karst topography, landscapes made of soluble rock like limestone or gypsum. Over eons, water seeps through cracks, dissolving the rock and carving out complex underground networks of conduits and caverns. A surface river flowing into one of these areas can simply plunge into a sinkhole, disappearing from sight. In southern Indiana, the appropriately named Lost River flows for 23 miles, but for 8 of those miles, it vanishes entirely, traveling through a network of caves before re-emerging at a spring. The world's largest known underground river is the Sistema Sac-Actin on Mexico's Yucatan Peninsula, a massive submerged cave system that stretches for over 230 miles. These hidden rivers are not just geological oddities. They are unique, lightless ecosystems, home to specially adapted creatures like blind cavefish and translucent crustaceans. They are the planet's secret waterways, flowing silently in the dark, reminding us that even after mapping the entire surface of the globe, there are still rivers out there whose full courses remain a profound mystery. Imagine holding a single grain of sand. Now imagine a force so patient, so relentlessly powerful, that it can use trillions of these tiny grains to slice a 1-mile-deep gash into the surface of a continent. That force isn't an imaginary superweapon, it's just water. Rivers are not just passive channels for water. They are the planet's primary architects, tirelessly grinding down mountains and building new worlds, one grain of sand at a time. And the scale of their work will shatter everything you thought you knew about the landscape around you. We often think of canyons as scars on the earth, but they are more like masterpieces. And for our 43rd fact, the grandest masterpiece of all, the Grand Canyon, wasn't carved by a single cataclysmic event, but by the Colorado River acting as a liquid saw blade for over 5 million years. The river didn't just wash away soft dirt, it sliced through layer after layer of dense rock, sandstone, limestone, and even granite. It did this through abrasion, using the very sediment it carried, sand, silt, and pebbles as its cutting tools. Every single second, the river scours its bed, carrying away microscopic pieces of the continent. Over the vastness of geologic time, this adds up to the removal of over 1,000 cubic miles of rock, all transported downstream toward the ocean. To put that in perspective, if you took all the material the Colorado River carved out to form the Grand Canyon, you could build a wall 3 feet wide and 10 feet high that could circle the Earth's equator more than 4 times. It is the ultimate testament to the idea that with enough time, the softest substance can conquer the hardest. But this raises a fascinating question. Why did the Colorado River stop digging? Why isn't the Grand Canyon 10 miles deep? That brings us to a fundamental law of river physics for our 44th fact. Every river has a base level. A river's primary job is to flow downhill, and it can only erode the land down to the level of the body of water it flows into. For most major rivers, the ultimate base level is sea level. You can think of it as a floor the river cannot cut beneath. The Colorado River, as it approaches the Gulf of California, loses its downward momentum and can't erode any further. But this base level isn't always the ocean. A river flowing into a large lake, like Lake Mead, will have its base level set by the lake's surface elevation. This is why you see features like waterfalls and rapids. A waterfall is simply a river flowing over a resistant rock layer, frantically trying to erode its way down to its base level. If sea levels were to drop dramatically, rivers around the world would be re-energized, gaining a steeper gradient and beginning to carve even deeper into the continents. So we know rivers are masters of demolition, grinding up rock and hauling it away. But what happens to all that debris? Well, for fact 45, sometimes a river drops everything all at once in a spectacular landform known as an alluvial fan. Picture a vast, powerful river full of energy from tumbling down a steep mountain canyon. The moment it bursts out of that confined canyon onto a wide, flat valley floor, it's like a sprinter hitting a wall of deep mud. Its velocity plummets instantly. It can no longer carry its heavy load of boulders, gravel, and sand. So it dumps it. The heaviest material drops first, right at the canyon's mouth, and finer materials are carried a bit further. Over thousands of years, as the river channel shifts back and forth, this deposit builds up into a beautiful cone-shaped or fan-shaped feature. These alluvial fans are not just geological curiosities. They are often incredibly fertile areas, creating oases of agriculture in arid regions like Death Valley or the Great Basins of Central Asia, where ancient civilizations first took root. Alluvial fans are impressive, but they are just the opening act for a river's creative power. For the truly grand finale of land creation, we turn to fact 46. The river delta. While an alluvial fan is built from coarse material at the foot of mountains, a delta is constructed from the finest silt and clay at the very end of a river's journey, where it meets a sea or a lake. Here, the river's current finally dies, and it lays down the last of its payload. And some of these deltas are mind-bogglingly huge. The largest on Earth isn't the Nile or the Mississippi, but the Ganges-Brahmaputra Delta in Bangladesh and India. This single delta, built by two of Asia's mightiest rivers, covers an area of over 40,000 square miles. That's larger than the entire country of Portugal. It is a constantly changing landscape of shifting islands, channels, and mangrove forests known as the Sundarbans. This delta is so vast and fertile that it supports over 130 million people, making it one of the most densely populated regions on the planet. This isn't just a feature on the coast. The rivers have literally built a massive extension of the Asian continent out into the ocean. But a river's sculpting work isn't just happening at the mountains or the sea. It's happening all along its middle journey, where it often gets a little lazy and begins to wander. This brings us to fact 47, and one of the most elegant landforms a river can create, the oxbow lake. As a river flows across a relatively flat plain, the fastest-moving water swings to the outside of a bend, eroding the bank. Simultaneously, the slower water on the inside of the bend deposits sediment. This process causes the river's curves, or meanders, to become more and more exaggerated over time, like a looping piece of string. Eventually, a meander can become so extreme that the narrow neck of land between the start and end of the loop gets incredibly thin. During a flood, the river, always seeking the most efficient path, will punch straight through that neck, creating a new, shorter channel. The old, C-shaped meander is abandoned, and sediment deposited by the new channel seals it off, leaving behind a perfectly curved, crescent-shaped lake, a ghost of the river's former path. A river cutting a corner is one thing, but sometimes the competition between rivers gets far more aggressive. Prepare yourself for fact 48, the astonishing phenomenon of river capture, also known as stream piracy. This is exactly what it sounds like. One river can literally steal the water from another. It happens when two rivers flow near each other, but one is more powerful, has a steeper gradient, or is cutting through softer rock. The more aggressive river can erode its valley backward, a process called headward erosion, pushing its source further and further into the landscape. If its advancing valley wall breaches the valley of the neighboring, weaker river, it will capture its flow. The water from the beheaded river is diverted into the channel of the pirate stream, leaving its old lower course high and dry or significantly reduced. Geologists have found countless examples of this planetary-scale larceny, including the ancient Taze River in North America, a massive prehistoric river system that was dismembered and captured by the ancestors of the modern Ohio River. Now, let's combine these last two ideas. What happens when a lazy, meandering river, a river that should be forming oxbows on a flat plain, is suddenly subjected to immense geological forces? The answer is our 49th fact, the breathtaking spectacle of an incised meander. This occurs when the land beneath a mature, winding river begins to uplift. Instead of being able to shift its course, the river is trapped in its existing path. It has no choice but to start carving its winding pattern straight down into the rising bedrock. The river maintains its sinuous, looping shape, but transforms it from a feature on a flat floodplain into a deep, winding canyon. The goosenecks of the San Juan River in Utah are the quintessential example, where the river snakes back and forth for over 6 miles while only advancing 1.5 miles westward, all within a canyon over 1,000 feet deep. It's like a fossil of the river's ancient, gentle path, preserved forever in solid rock by its own relentless cutting power. From carving canyons to building new lands, pirating water, and etching their memory into stone, rivers are the undisputed, eternal sculptors of our world. Forget the dense jungles and the sprawling savannas for just a moment. What if the most concentrated, life-packed real estate on our entire planet isn't land at all, but the thin, shimmering ribbons of water that carve through it? We've journeyed through the power and geology of rivers, but now we dive headfirst into their living, breathing soul. Because here's a staggering reality to start with. Freshwater rivers, lakes, and wetlands cover less than 1% of the Earth's surface, yet they are home to an astonishing 10% of all known animal species. Let that sink in. A tiny fraction of the planet's area holds a massive share of its life, including a third of all vertebrate species. This isn't just a habitat, it's a biodiversity hyper-hotspot. From the smallest microorganisms to the largest predators, rivers are the crowded, bustling, and often chaotic arteries of life on every single continent except Antarctica. They are nature's grand experiment in density, proving that when you add water, life doesn't just show up, it explodes in a symphony of unbelievable diversity. And speaking of unbelievable, let's travel to the turbulent, muddy waters of the Congo River Basin. Here, the symphony plays a particularly fearsome tune. This is the only place in the world you can find the Goliath tigerfish, a creature that looks like it swam straight out of a prehistoric nightmare. This is no ordinary fish. Growing over a meter long and weighing up to 70 kilograms, its most terrifying feature is a set of 32 enormous dagger-like teeth, each interlocking perfectly like a bear trap. These teeth are so formidable that the tigerfish is one of the few freshwater fish known to actively hunt and prey on birds in mid-flight, leaping from the water to snatch them from the air. It's a powerful, apex predator whose aggression and raw strength make it a legend among anglers and a testament to the extreme evolutionary pressures that a mighty river like the Congo can create. But not every key player in a river's ecosystem is a fearsome predator. Some of the most influential are, in fact, master builders. Enter the beaver, North America's largest rodent and a creature so impactful it's known as a keystone species. The beaver isn't just living in the river, it is fundamentally reshaping it. By felling trees and constructing intricate dams of wood, mud, and stone, a single family of beavers can transform a fast-flowing stream into a complex network of ponds, marshes, and wetlands. This act of engineering has a massive ripple effect. The newly created still waters become nurseries for fish, prime real estate for amphibians like frogs and salamanders, and a magnet for waterfowl. The surrounding vegetation flourishes, attracting moose and deer. By slowing the water, these dams also help purify it and prevent downstream flooding and erosion. A single beaver dam is the foundation of an entire neighborhood of biodiversity, making this humble rodent one of the planet's most important ecosystem engineers. The incredible web of life doesn't just start with the big animals, though. It begins with something most of us would simply call slime. If you've ever slipped on a river rock, you've personally met a biofilm. But that slippery coating is far from just simple gunk. It is, in fact, a complex, multi-layered, microscopic city. This biofilm is a thriving community of bacteria, algae, fungi, and protozoa, all living together in a protective matrix of secreted slime. This isn't just a random collection, it's a highly organized ecosystem that forms the absolute base of the river's food web. The algae photosynthesize, creating energy from sunlight. The bacteria break down organic matter, recycling nutrients. And countless tiny invertebrates, known as macroinvertebrates, graze on this biofilm like cattle in a pasture. Without this slimy, underappreciated layer, the entire food chain above it, from insects to fish to birds, would simply collapse. From the microscopic to the truly magnificent, let's head to the murky waters of South America to meet an animal that defies expectations. The Amazon river dolphin, or boto, is famous for its almost mythical pink hue, which deepens when it gets excited. But its most mind-blowing feature isn't its color, it's what's inside its head. The boto possesses the largest and most complex brain of any dolphin on Earth. Incredibly, its brain capacity is about 40% larger than a human's. While brain size isn't a direct measure of intelligence, the sheer complexity and surface area of the boto's brain, with its numerous folds and convolutions, suggests a level of cognitive ability that scientists are still struggling to understand. They navigate the incredibly complex, often flooded forest environment of the Amazon with sophisticated echolocation, demonstrating remarkable problem-solving skills and social behaviors. It's a powerful reminder that some of the planet's greatest minds aren't walking on land, but swimming through its rivers. Of course, a river's symphony isn't just composed of animals. The plants are a critical section of the orchestra. Life in a current is tough, so riverside, or riparian, vegetation has evolved incredible adaptations to survive. Trees like willows and cottonwoods have deep, fibrous root systems that act like living rebar, holding riverbanks together and preventing erosion. But perhaps the ultimate river plant specialist is the mangrove. Found in the brackish estuaries where rivers meet the sea, mangroves are masters of a challenging environment. They thrive in saltwater thanks to roots that can filter out salt and specialized breathing roots called pneumatores that stick up out of the mud to get oxygen. This dense tangle of roots not only protects coastlines from storm surges, but also creates one of the most vital nursery habitats on the planet for countless species of fish, crabs, and shrimp. They are the guardians of the transition zone, a living wall where the river's story merges with the ocean's. And that brings us to a final, profound point. The vibrant life within a river doesn't just exist for its own sake. It tells a story about the water itself. Certain highly sensitive creatures act as living barometers for a river's health. These are known as indicator species. For example, the larvae of mayflies, stoneflies, and caddisflies are extremely intolerant of pollution. If you find a river teeming with these specific insects, it's a clear sign that the water is clean and well oxygenated. Conversely, their absence is a silent, screaming alarm that something is wrong. By simply studying the symphony of life, by listening to which instruments are playing and which have fallen silent, scientists can read the health of an entire watershed. These tiny creatures are the river's canaries in the coal mine, proving that the smallest voices in the ecosystem are often the ones that tell the most important truths. Take a look at your hands. The civilization that allowed you to be here watching this, the very concepts of writing, law, and government, all of it began with mud. Not just any mud. It was the rich, dark, fertile mud deposited by the floodwaters of ancient rivers. We've seen how rivers carve canyons and shape continents, but their greatest masterpiece wasn't sculpted from rock. It was sculpted from us. And our story begins in a sun-scorched land between two legendary waterways. 59. The world's first cities didn't spring up because of a brilliant idea, but out of a desperate necessity created by the Tigris and Euphrates rivers. In ancient Mesopotamia, farming was a gamble. Unlike the gentle, predictable river we're about to visit, these two could be violent and erratic. Their floods could arrive at the wrong time, wiping out crops. The solution was humanity's first great engineering project, irrigation. But digging canals and building reservoirs to trap the precious water required unprecedented cooperation. You couldn't do it alone. You needed a village. That village needed leaders to organize the labor. They needed rules to decide who got water and when. And most importantly, they needed a way to track the grains stored in their shared granaries. That need gave us the earliest form of writing, cuneiform, etched into clay tablets. Our entire written history started as an accounting system for grain, a system made necessary by the challenge of taming two wild rivers. From the unpredictable chaos of Mesopotamia, we journey south to a civilization defined by the complete opposite, a river that operated with the precision of a celestial clock. 60. Ancient Egypt wasn't just located near the Nile, the civilization was the Nile. The Greek historian Herodotus famously called Egypt the gift of the Nile, and he wasn't exaggerating. Every single year, around the same time in late summer, the river would swell and gently overflow its banks. When the waters receded, they left behind a layer of incredibly rich black silt, a natural fertilizer that made the desert bloom. This astonishing predictability meant Egyptian farmers could plant their crops with near absolute certainty of a harvest. This stability, a direct result of the river's rhythm, allowed for a culture that lasted for 3,000 years. Their entire calendar was based on the 3 seasons of the Nile: Akhet, the inundation; Peret, the growing season; and Shemu, the harvest. They even built ingenious devices called nilometers, staircases and pillars descending into the river with markings to measure the flood's height, allowing them to predict the coming harvest and set tax rates accordingly. The river wasn't just a resource, it was the entire operating system for their civilization. But while the Nile's consistency built a timeless empire, the shifting moods of another great river may have erased one from history. Along the banks of the Indus River, a civilization flourished that was, in some ways, even more advanced than its Egyptian and Mesopotamian contemporaries. The people of the Indus Valley built meticulously planned cities like Mohenjo-Daro with grid-like streets and the world's first known urban sanitation systems. We're talking about houses with private baths and a complex network of covered drains and sewers, an engineering marvel not seen again on that scale for thousands of years. Their entire society was a testament to sophisticated water management. Yet this incredible civilization vanished around 1900 BCE. While the exact cause is debated, a leading theory points directly at the river that gave them life. Evidence suggests the powerful Indus may have drastically changed its course or experienced catastrophic flooding, disrupting the agricultural base and trade routes they depended on, eventually forcing the population to abandon their magnificent cities, leaving them to be swallowed by the sand. This dual nature of a river, a force of creation and of utter destruction, is nowhere more apparent than with the waterway that birthed the Middle Kingdom. 62. China's Yellow River, or Huanghe, is often called the cradle of Chinese civilization, but it's just as famously known as China's sorrow. Its signature color comes from carrying an immense quantity of fine, nutrient-rich silt called loess, eroded from a vast plateau. When the river floods, it deposits this incredibly fertile soil, creating the agricultural heartland of ancient China. But that same silt is also its curse. The sediment constantly raises the riverbed, so for centuries, people have built higher and higher dikes to contain the flow. The result is an astonishing phenomenon where the river actually flows above the surrounding farmland, held in place only by man-made levees. When those levees inevitably breach, the results are cataclysmic, unleashing devastating floods that have claimed millions of lives throughout history. This constant, high-stakes battle to control the river required massive, coordinated labor, which historians believe was a key driver in the formation of China's first centralized dynasties. The river forced unity because survival depended on it. So rivers created the fertile land that anchored civilizations in one place. But they also did the exact opposite. They became the arteries that allowed them to move and expand. Long before the invention of the paved road or the wheel, rivers were humanity's first highways. Moving goods, armies, or even just information over land was slow, difficult, and dangerous. A simple barge floating downstream could carry 100 times the cargo of a donkey train in the same amount of time. This made rivers the undisputed channels of trade and communication. The Roman Empire, for example, used the Rhine and Danube rivers not just as defensive borders, but as critical supply lines, allowing them to rapidly move legions and provisions to the frontiers of their vast territory. The flow of the river became the flow of commerce, ideas, and power, connecting isolated communities and allowing local settlements to grow into sprawling empires. When your entire existence, your food, your safety, your connection to the world, is tied to a single, powerful, moving entity, it's only natural to see it as something more than just water. For virtually every early civilization, the local river was a deity, a living, spiritual being. To the people of India, the Ganges wasn't just a river, she was Ganga, a goddess whose waters could purify sins and grant passage to the heavens. In ancient Egypt, the god Hapi wasn't the god of the Nile, he was the personification of the annual flood itself. Rivers were seen as sacred thresholds, places where the world of the living met the realm of the gods. They were sources of creation myths, the settings for heroic journeys, and the destinations for holy pilgrimages. This spiritual reverence reveals a profound truth. Our ancestors understood on a fundamental level that their lives flowed directly from the river, and their debt was not just physical, but sacred. This brings us to one final incredible gift from the rivers. With thriving populations, stored wealth, and complex societies came a whole new set of problems: disputes over land, theft, and questions of fairness. 65. The very first written legal codes were created to solve problems created by rivers. Think about it. If the annual flood washes away the stones marking the boundary between your farm and your neighbor's, how do you re-establish it? If an upstream farmer diverts too much water from an irrigation canal, leaving downstream fields to wither, what is a just outcome? These were the precise issues addressed by laws like the famous Code of Hammurabi from Mesopotamia. This ancient set of 282 laws laid out rules for everything from property rights and trade to family law and professional conduct. It was a blueprint for social order, born from the challenges of living together in a complex agricultural society dependent on the shared and often contentious resource of river water. The river didn't just give us cities, it gave us the very concept of organized justice. What if I told you there's a river so powerful that even the gods are terrified of it? A river whose waters can bind an immortal to an unbreakable oath, with consequences so dire they would rather face any other punishment in the cosmos. We often think of rivers as channels of water, but for most of human history, they were so much more. They were lifelines, deities, and pathways to the afterlife. They were places where the veil between our world and the world of myth grew impossibly thin. So let's leave the banks of the familiar and journey into those legendary waters where belief and reality flow together as one. We begin in the darkness of the ancient Greek underworld, a place crisscrossed by 5 infernal rivers. But one of them stands above all others in sheer, terrifying power. We're talking about the river Styx, whose name literally means hate or detest. This wasn't just some murky stream, it was a cosmic boundary. And our 67th fact is that the Styx served as the ultimate binding contract for the gods of Olympus. When a god swore an oath upon the river Styx, there was no turning back. Zeus himself established this tradition. To break such an oath meant a punishment almost beyond comprehension. The offending deity would be forced to drink from its waters, causing them to lose their voice and fall into a coma-like state for a full year. After that, they would be exiled from the company of the gods for 9 more years. It's the reason the goddess Thetis famously dipped her infant son, Achilles, into the Styx, holding him by the heel to grant him invulnerability. Its waters held the power of protection and punishment, making it the most feared and respected river in all of mythology. From a river that symbolized the finality of death in the West, we travel east to a river that represents eternal life and purification for over 1 billion people. The river Ganges, known in India as Ganga, is far more than a body of water. She is a goddess. And the story of her arrival on Earth is our 68th amazing fact. According to Hindu mythology, Ganga once flowed only in the heavens. A great king, Bhagirath, performed intense penance for 1,000 years to persuade her to descend to Earth to purify the ashes of his ancestors. But Ganga's power was so immense, her direct descent would have shattered the planet. So, the god Shiva, one of the principal deities of Hinduism, agreed to help. He stood atop the Himalayas and caught the celestial river in his matted hair, breaking its fall and allowing it to flow gently onto the plains below. To this day, the Ganges is considered sacred, a tirtha, which means a crossing point between heaven and earth. Devotees believe that bathing in its waters washes away a lifetime of sins, and that having one's ashes scattered in the river ensures liberation for the soul. The Ganges isn't the only river where faith and flowing water are inseparable. A much smaller, dustier river in the Middle East holds a sacred place at the very core of 3 world religions. The River Jordan is modest in size, but its spiritual significance is immeasurable. For our 69th fact, we look at its foundational role in the Abrahamic faiths. For ancient Israelites, it was both a barrier and a gateway. After 40 years in the desert, they miraculously crossed the Jordan on dry ground to finally enter the Promised Land. This act of divine intervention cemented the river as a symbol of transition and deliverance. But its most famous moment came centuries later when John the Baptist chose its banks for his ministry. It was in the waters of the Jordan that Jesus was baptized, an event considered a cornerstone moment of Christianity, marking the beginning of his public ministry. Today, pilgrimage sites dot its banks, where believers from around the world come to be baptized, connecting with a spiritual tradition that is thousands of years old. Now, while the Styx is the most famous river of the Greek underworld, it wasn't the one you encountered first. The actual watery welcome mat to Hades was a different river entirely, and the fact it's often overlooked makes it even more intriguing. For our 70th fact, let's talk about the Acheron, the River of Woe. According to the myths, it was across the Acheron, not the Styx, that the ghostly ferryman Charon would transport the souls of the newly dead. It was a vast, marshy river that formed the true border of the underworld, and souls had to pay Charon a coin for passage. Those who couldn't pay were doomed to wander its banks for 100 years. What makes the Acheron so fascinating is that it's a real river you can visit today in the Epirus region of Greece. Its cool waters flow from the mountains and even disappear underground for a stretch, a geographical quirk that likely fueled ancient beliefs that it led to another world. It's a place where you can physically stand on the banks of a mythological entrance to the land of the dead. While the Greeks imagined rivers flowing to the underworld, on the other side of the planet, a mighty river was revered as the literal source of an entire civilization. The Yellow River, or Huanghe, is often called the Mother River of China, but its legacy is one of both creation and destruction. This duality is central to our 71st fact. The very founding of Chinese civilization is based on the taming of this river. For centuries, the Yellow River's unpredictable and catastrophic floods, a result of the immense amount of silt it carries, plagued the early inhabitants of the region. The great founding myth of China revolves around a figure named Yu the Great. Instead of trying to block the floods with dams like his predecessors, Yu spent 13 years dredging new channels to guide the water to the sea, working so tirelessly that he passed his own home 3 times without stopping. His success in controlling the river demonstrated that harmony with nature, rather than brute force, was key. This feat earned him such reverence that he became the ruler and established the Jia dynasty, China's very first. The river wasn't just a challenge to be overcome, it was the force that forged a nation's identity. Of course, you can't talk about rivers forging nations without paying tribute to the undisputed king, the Nile. The civilization of ancient Egypt wasn't just built alongside the Nile. Its entire existence was a direct product of the river's unique rhythm. For our 72nd fact, the Nile wasn't just water, it was the physical manifestation of the god's will. The Egyptians didn't understand the distant mountain rainfall that caused the annual flood. Instead, they believed the inundation was caused by the tears of the goddess Isis, weeping for her slain husband Osiris. The flood itself was personified as the god Hapi, who brought the fertile black silt that made agriculture possible in the desert. The river's rhythm dictated everything.
الكالندر المصري كان 3 مواسم: أخت الفيضان، بارت الgrowing، وشيمو الحصاد. A river was also a highway to the afterlife, with tombs built on the west bank, where the sun, the god Ra, set each day on his journey into the underworld. For the Egyptians, the Nile was life, death, and eternity all in one.
For thousands of years, these stories of living, divine rivers were confined to the realms of myth and religion. But what happens when an ancient spiritual belief is written into modern law? Our 73rd fact brings us to a groundbreaking moment where mythology truly meets the mainstream. In 2017, the Wanganui River in New Zealand became the first river in the world to be granted legal personhood. This landmark decision wasn't just an environmental protection act. It was the culmination of a 140-year struggle by the Wanganui Maori people to have their worldview legally recognized.
To the Maori, the river is not a resource, it is an ancestor, a living being with a spirit. And they have a saying, "I am the river and the river is me." By granting it the same legal rights as a human, the law recognizes the river as an indivisible, living whole. It can now have legal guardians appointed to speak on its behalf, sue those who harm it, and own property.
This historic act has transformed a deeply held spiritual belief into a tangible legal reality, creating a new and powerful way for humanity to reconsider its relationship with the natural world. Now, we've journeyed down rivers that are impossibly deep, incredibly long, and powerful enough to shape continents.
But what happens when you take a river and place it in the most hostile environments imaginable? What if I told you that some of the planet's largest, most significant rivers flow in places you can't even see them, in total darkness, under miles of solid ice? We're about to explore the absolute extremes, where water finds a way in the hottest and coldest places on Earth. Let's begin at the bottom of the world, in Antarctica, a continent buried under an ice sheet averaging over a mile thick. You'd think it's the last place to find flowing water, but beneath that colossal weight of ice lies a hidden world. Fact number 76, Antarctica is crisscrossed by a massive, continent-spanning network of subglacial rivers and lakes, hundreds of them. These aren't tiny trickles. Some of these river systems are hundreds of miles long, flowing through valleys and over mountains that haven't seen sunlight in 15 million years. How is this even possible? The immense pressure of the ice on top lowers the freezing point of the water below, while geothermal heat from the Earth's crust warms it from the bottom. This creates a thin layer of meltwater that lubricates the base of the entire ice sheet, and this water collects, forming vast flowing rivers in a world of perpetual night.
Scientists use ice-penetrating radar to map these ghostly streams, revealing a dynamic plumbing system that dictates how the entire Antarctic ice sheet moves and melts. And if you think that's mind-bending, travel with us to the other pole, to Greenland. For decades, scientists couldn't account for a massive amount of meltwater that seemed to simply vanish from beneath Greenland's ice sheet. They knew it was draining somewhere, but they couldn't find the exit. The answer was more spectacular than anyone imagined. Fact number 77. Hidden beneath the Greenland ice is a single, colossal subglacial river that carved a canyon longer than the Grand Canyon. Discovered using the same radar technology, this so-called dark river runs for over 460 miles, from the center of Greenland all the way to the northern coast, where it empties into the Arctic Ocean. At points, its canyon is half a mile deep. This isn't an ancient relic. It's an active feature, a mega river that is currently draining a significant portion of the ice sheet's meltwater. It's a complete, world-class river system with its own V-shaped valleys and tributaries, a geographic titan that has been operating completely unseen by human eyes for millennia. Having an enormous river grinding away under a glacier is one thing, but what happens when that water needs to get out in a hurry? For the answer, we look to Iceland, the land of fire and ice. Here, volcanoes and geothermal vents are often buried right under the glaciers. When one erupts, it can melt an unbelievable volume of ice almost instantly, creating a huge lake trapped beneath the glacier. The pressure builds and builds until it doesn't. Fact number 78. Iceland is home to a phenomenon called a jökulhlaup, a catastrophic glacial outburst flood where a subglacial river bursts free with a discharge rate that can temporarily dwarf the Amazon River. One day, it's a silent, frozen landscape. The next, a wall of black, sediment-filled water, icebergs, and boulders explodes from the glacier's edge. The 1996 Jökulhlaup from the Vatnajökull Glacier peaked at a flow rate of over 1.6 million cubic feet per second. That's more than twice the peak flow of the Amazon and powerful enough to wash away bridges, roads, and anything else in its path. It is one of the most violent and sudden expressions of a river's power on the entire planet. From the crushing, frozen dark of the poles, let's journey to the complete opposite extreme, the blistering, sun-baked desert. Here, riverbeds can lie bone dry for years, sometimes even decades, looking like nothing more than sandy, rock-strewn highways to nowhere. They seem utterly lifeless. But this is a deception. Fact number 79. These dry riverbeds, often called wadis or arroyos, are home to some of the world's most dangerous flash floods, capable of turning a dry ditch into a raging, life-threatening torrent in mere minutes. A thunderstorm miles away in distant mountains can send a wave of water racing down the channel with terrifying speed and no warning. The flood wave can be dozens of feet high, carrying a slurry of sand, rocks, and debris that acts more like liquid concrete than water. This is why you'll often see signs in desert parks warning you not to camp in dry riverbeds. An ephemeral river is still a river, and its memory of how to flow is terrifyingly permanent. But not all desert rivers are defined by their absence. Some perform an act of pure magic. Consider a river that begins its life in the well-watered highlands of Angola, flowing south. It heads directly for the driest, most forbidding landscape imaginable, the Kalahari Desert in Botswana. Logic dictates it should evaporate, vanish into the sand. Instead, it does something extraordinary. Fact number 80. The Okavango River never reaches the sea. Instead, it fans out into the heart of the Kalahari, creating the Okavango Delta, the world's largest inland delta and a sprawling wetland oasis. This one river single-handedly transforms over 5,700 square miles of parched sand into a vibrant, watery maze of lagoons, channels, and islands. It's an ecological miracle. This annual flood arrives during the dry season, drawing in one of the greatest concentrations of wildlife in Africa: elephants, lions, leopards, and countless birds, all dependent on a river that chose to create an Eden rather than die in the sand. It's a perfect example of an endorheic river, a basin that keeps its water all to itself. Now, we've seen cold rivers, hidden rivers, and life-giving desert rivers. But what about a river that's not just hot, but lethally, mythically hot? In the heart of the Peruvian Amazon, there is a river spoken of in local legends for generations, a place guarded by shamans. It was thought to be just a myth until a geoscientist named Andres Russo, hearing the stories from his grandfather, set out to find it, and he did. Fact number 81. Deep in the Amazon is the Shenay Timpishka, the Boiling River, a 4-mile-long tributary where the water temperature averages 186 degrees Fahrenheit and can reach over 200 degrees. That's hot enough to brew tea, and tragically, hot enough to literally cook small animals that fall in. For a long time, the source was a mystery. It isn't volcanic. The incredible heat comes from a fault-fed geothermal system, where hot water from deep within the earth pours out into the river at an enormous rate. It's a sacred, astonishing place, a living legend that turned out to be breathtakingly real. Finally, for our last stop in these extreme environments, let's travel to the Australian outback. Deserts and extreme temperatures aren't just about the here and now, they're also about deep time. Flowing through the arid heart of Central Australia is a river that defies our very sense of time. When you see it, you see a river that has carved its way through the McDonnell Ranges, which seems normal. But the story is backwards. Fact number 82. The Finke River is widely considered one of the oldest rivers in the world, with a course that predates the very mountains it cuts through. Geologists estimate that parts of its path are over 300 million years old. This means the Finke River was already flowing in its ancient bed when the tectonic forces of the Alice Springs orogeny between 300 and 400 million years ago began to slowly push the mountains up. Instead of being diverted, the river was persistent enough, its flow steady enough over geological time, that it simply kept cutting down as the land rose up. It's a river that flowed before the dinosaurs, a waterway so ancient it watched mountains being born and ground them away as they grew. It's a quiet, humble reminder that even in the driest places, a river's patience can outlast stone itself. Imagine a river born from highland rain that carves a path over 1,000 kilometers across a continent. It swells with the lifeblood of the land, its current strong and determined, pushing ever onward toward the sea. Except it never gets there. This isn't a riddle. It's the astonishing reality of Botswana's Okavango River. For our 80th fact, this colossal waterway, after its epic journey through Angola and Namibia, reaches the Kalahari Desert and simply stops. It doesn't pour into an ocean or a Great Lake. Instead, it fans out, branching into a labyrinth of channels, lagoons, and islands, creating the Okavango Delta, a sprawling 15,000 square kilometer wetland oasis in the middle of one of the world's great deserts. The river essentially sacrifices itself to the sand and sun, giving birth to one of the most biodiverse and wildlife-rich ecosystems on the planet. Over 95% of the river's water is ultimately lost to plant uptake and evaporation. It's a river that chooses to create a paradise rather than find an ocean, performing the ultimate vanishing act on a continental scale. So how does a river just surrender to the land? In many parts of the world, the ground itself is the magician. This brings us to fact 81, the phenomenon of the losing stream. This occurs when a river flows over a type of landscape called karst topography. Karst is formed from soluble rocks like limestone or gypsum. Over millennia, Water seeps into cracks, dissolving the rock and carving out a secret world of caves, conduits, and sinkholes just beneath the surface. When a river crosses this kind of terrain, it can find one of these openings and begin to drain away, like water down a bathtub drain. A perfect example is the appropriately named Lost River in Indiana. It flows above ground for a stretch before completely disappearing into a series of sinkholes. For the next 8 miles, it becomes a completely subterranean river, navigating a vast cave system before re-emerging at the surface, seemingly out of nowhere. It proves that sometimes a river's journey isn't just horizontal, but vertical, plunging into darkness only to be reborn miles away.
But not every disappearing act happens underground. Some rivers perform their vanishing trick in plain sight, under the relentless glare of the sun. Fact 82 takes us to the world's most arid regions, where we find rivers that die of thirst. These are rivers that flow through deserts, where the rate of evaporation is so extreme that the sun literally drinks the river dry before it can reach a larger body of water. The Amargosa River in the Mojave Desert is a phantom of a waterway. For most of its 185-mile course, it flows underground, but where it does surface, it creates precious, life-giving wetlands in places like Death Valley. Yet its ultimate fate is sealed. As it flows towards an area called Badwater Basin, the driest place in North America, its last vestiges of water are vaporized by the intense heat, leaving behind only cracked, salt-encrusted earth. It's a testament to the immense power of the sun and a stark reminder that in the battle between water and heat, water doesn't always win. Nature's disappearing acts are one thing, but what happens when humanity becomes the magician? This can have truly devastating consequences, which leads us to a more somber 83rd fact, the tragic tale of the Aral Sea and the 2 rivers that were meant to feed it. The Amu Darya and the Sur Darya, 2 of Central Asia's mightiest rivers, once flowed for thousands of kilometers before emptying into the Aral Sea, which was, at the time, the 4th largest lake on Earth. But in the 1960s, massive Soviet-era irrigation projects began diverting colossal amounts of water from both rivers to grow cotton and other crops in the desert. The rivers were bled dry. Their flow was reduced to a trickle, and they began to vanish long before reaching their destination. The result was one of the worst environmental disasters in history. The Aral Sea, starved of its lifeblood, has shrunk by over 90%, leaving behind a toxic, salty desert dotted with the rusting hulks of abandoned fishing boats. It's a powerful and heartbreaking example of how quickly we can make a river and the world it sustains disappear. From rivers we've made disappear, we turn to rivers that only occasionally choose to appear at all. Fact 84 introduces us to the strange world of ephemeral rivers. These aren't just small streams that dry up in the summer. They are often vast, ancient river systems that lie dormant, sometimes for years, as nothing more than a wide, sandy bed. They are ghosts waiting for a signal. That signal is rain, rare but torrential desert downpours. When the storms come, these dry channels can transform into raging, powerful torrents in a matter of hours. Australia's Todd River is a famous example. It cuts right through the desert town of Alice Springs, and for most of the year, it's a dry, sandy expanse. Its temporary nature is so ingrained in the local culture that the town hosts a famous event called the Henley-on-Todd Regatta, where teams race in bottomless boats running Flintstone-style down the dry riverbed. It's a hilarious celebration of a river that, for 350 days a year, simply isn't there. But what if a river didn't just fade away or dry up seasonally? What if it was stolen, practically overnight? That brings us to the incredible story of the Slims River in Canada for our 85th fact. For centuries, the Slims was a significant river fed by the meltwater of the colossal Cascavel's Glacier.
But in the spring of 2016, something unprecedented happened. Due to decades of glacial retreat from a warming climate, the glacier's melting edge receded past a crucial geological ridge. Over just 4 days, the vast majority of its meltwater, which had fed the Slims River for 300 years, abruptly changed course.
It was captured by a different river system, the Kaskawalsh River, which flowed in the opposite direction to a different ocean. Scientists call this phenomenon river piracy, and this was the first time it had been documented in modern history. The Slims River, starved of its source, shrank from a 150-meter-wide torrent to a mere trickle in less than a week. Its valley is now a dusty, windy plain, a landscape utterly transformed by a 4-day geological heist. Our final vanishing act is perhaps the most profound of all. It concerns a river whose disappearance was so complete it was lost not just from the landscape, but from human memory, becoming the stuff of legend for thousands of years. Fact 86 is about the search for the Saraswati River. Ancient Hindu texts, like the Rig Veda, written over 3,500 years ago, describe the Saraswati as a mighty, life-giving river, greater than even the Indus or the Ganges. Yet for centuries, no such river could be found on any map, leading many to believe it was purely mythological. But modern science has uncovered a different story. Using satellite imagery, hydrological studies, and archaeological evidence, researchers have traced the path of a massive, ancient riverbed buried beneath the sands of the Thar Desert. This paleochannel perfectly matches the descriptions of the mythical Saraswati. The evidence suggests this was once a real, spectacular river fed by Himalayan glaciers that supported ancient civilizations. It likely dried up around 4,000 years ago due to tectonic shifts and climate change, its memory preserved only in sacred hymns. The Saraswati isn't just a river that disappeared, it's a lost world rediscovered. What if the river you're looking at is just the beginning? What if, hundreds or even thousands of feet beneath the water, or buried under miles of solid ice, there was another river? A secret river, flowing in the dark, with its own currents, its own banks, and its own destination. This isn't science fiction. This is one of the most mind-altering realities on our planet, and we're about to dive in. We often think of Antarctica as a static, frozen continent, a wasteland of ice. But this is a profound misunderstanding. Hidden from sight, beneath 2 miles of unimaginably heavy ice, entire river systems are actively carving their way through the continent's bedrock. It's a fact that completely redefines what we consider a riverine environment. These subglacial rivers, some stretching for hundreds of miles, are fed by the immense pressure of the ice sheet above them, which lowers the melting point of the ice at the very bottom. This creates a constant supply of meltwater that gathers into channels and flows towards the sea, lubricating the base of the ice sheet as it goes. Scientists use ice-penetrating radar to map these ghostly waterways, revealing a complex network that rivals surface river systems in its scale. They've even drilled down and sampled the water, finding microbial life that has been isolated from the rest of the world for millions of years, thriving in total darkness and crushing pressure. It's a shadow biosphere, an alien world running on chemistry we are only just beginning to understand, all powered by rivers no human eye will ever see directly. But you don't need to go to Antarctica to find a river beneath a river. In fact, almost every single river and stream you've ever seen has its own hidden secondary river flowing just beneath it. This isn't a separate channel of water, but something far more intricate, a saturated, life-filled zone known as the hyporeic zone. Imagine the riverbed isn't a solid floor, but more like a sponge made of gravel, sand, and sediment. Water from the main river channel constantly flows down into this sponge, travels downstream through the tiny spaces between particles, and then seeps back up into the main channel further on.
This subterranean flow is a critical, living part of the river. It acts as a massive natural filter, with microbes in the sediment breaking down pollutants. It's also a vital refuge for countless tiny invertebrates and fish larvae, protecting them from predators and harsh currents in the main channel. This zone can extend for yards or even miles out from the visible banks of the river, meaning the true river is far wider and deeper than it appears. It's the river's circulatory system, its lungs, and its nursery, all operating completely out of sight. Now, let's take that concept and expand it to the size of an entire country. Mexico's Yucatan Peninsula is famous for its lush jungles, but look around and you'll notice something strange. There are almost no surface rivers. So where does all the rainwater go? It goes down. The entire peninsula is a porous limestone shelf, and beneath it lies one of the most extensive and breathtaking underground river systems on Earth. Over millennia, rainwater has carved out an incredible labyrinth of submerged caves and tunnels. The gateways to this underwater world are the famous cenotes, dazzling sinkholes that form when the ceiling of an underground cavern collapses. These aren't just swimming holes, they are windows into a colossal, hidden freshwater network that sustains the entire region's ecosystem. Divers have mapped hundreds of miles of these submerged passages, connecting different cenotes into vast systems like Sacaktun, the longest known underwater cave system in the world. It's a stark reminder that some of the planet's greatest rivers are completely invisible from the surface, flowing silently through a world of stone darkness. But even that pales in comparison to what was discovered at the bottom of the Black Sea. This isn't a river of fresh water flowing through rock. This is a river of salt water flowing through other salt water. In 2010, scientists using an autonomous underwater vehicle discovered a massive, active undersea river winding its way along the seabed, more than 1,100 feet below the surface. This is a true river in every sense of the word. It has clearly defined banks, a floodplain, rapids, and even waterfalls that would dwarf many on land. It's estimated to be over 37 miles long, half a mile wide in places, and flows at a brisk 4 miles per hour. If it were on the surface, its flow rate would make it the 6th largest river in the world by volume of water discharged. Think about that for a second. A river larger than the Rhine, flowing in the crushing blackness of the deep sea. It carves channels into the seabed, just like a surface river, carrying nutrient-rich sediments and depositing them in a deep-sea delta. It is an entire, self-contained river system operating in a completely alien environment. So how is that even possible? How can a river flow underwater? The secret lies in a fascinating property of water called a chemocline. A chemocline is simply a sharp, vertical gradient in the concentration of a dissolved substance. In this case, the river is made of extremely salty water that has flowed into the Black Sea from the Mediterranean through the Bosphorus Strait. This water is much denser and heavier than the less salty water of the Black Sea itself. Because of this density difference, the two waters don't mix easily. Instead, the hypersaline Mediterranean water sinks to the bottom and begins to flow along the seabed under its own weight, pulled by gravity down the continental slope just like a regular river. The boundary between the super salty river water and the less salty ambient seawater is the chemocline, which acts like an invisible riverbank containing the flow. It's the exact same principle that allows you to float a layer of fresh water on top of salt water in a glass, but scaled up to a monstrous geological level. This phenomenon of a hidden flow isn't just at the bottom of the sea. What if I told you the mighty Amazon River has a secret twin? Deep beneath the Amazon basin, flowing in the same direction but some 2.5 miles underground, is the so-called Hamza River. Now, this isn't a river in the conventional fast-flowing sense. It was discovered by scientists studying temperature variations in deep oil wells, which revealed a massive, slow-moving body of groundwater.
River is actually water seeping incredibly slowly through porous sedimentary rock, moving at a rate of only a few hundred feet per year. But its scale is almost incomprehensible. It's believed to be over 3,700 miles long, the same length as the Amazon, but up to 250 miles wide in places. Its total flow rate is enormous, estimated at around 3,000 cubic meters per second, which is greater than that of the River Thames. While its sluggish pace disqualifies it as a river for some geologists, the sheer volume of water moving in a consistent direction deep within the Earth's crust, mirroring the path of the world's greatest surface river, is a mind-boggling discovery. It suggests the planet's plumbing is far more complex and layered than we ever imagined. Sometimes, these hidden rivers aren't just geological curiosities. They are echoes of history, buried by time itself. Many have heard of the legendary Pishin River, one of the 4 rivers said to flow from the Garden of Eden in ancient texts. For centuries, it was considered pure myth, a lost landmark from a forgotten world. But using advanced satellite imagery and radar data, scientists have uncovered compelling evidence of its existence. They have mapped a distinct, dry riverbed now completely buried beneath the sands of the Arabian Peninsula.
Kuwait River, as it's now called, was once a massive waterway over 600 miles long, flowing from the mountains of western Arabia all the way to the Persian Gulf. It would have created a fertile green corridor through what is now barren desert, perfectly matching ancient descriptions of the Pishin. It's believed the river dried up around 3,500 to 2000 BC due to climate change. Today, it exists only as a ghostly channel in the bedrock, a subterranean map of a lost world. It is a powerful testament to how even the mightiest rivers can vanish from the surface, becoming nothing more than a secret held by the earth beneath our feet. What if I told you there's a river on Earth that flows in 2 directions at once, feeding 2 entirely different oceans? Or another that boils its water without a single volcano in sight? We think a river is simple, water flowing downhill to the sea. But the planet is full of hydrological rebels, rivers that break all the rules. We've charted the longest and deepest. Now we're heading off the map into the realm of the truly bizarre to find the planet's most puzzling rivers. Let's start in South America with a riddle that baffled explorers for centuries. The Cassiquiare Canal isn't man-made. It's a natural river that connects 2 of the world's largest river systems, the Orinoco and the Amazon. Think of it as a natural corridor. Water flows from the upper Orinoco, travels over 200 miles through the Cassiquiare, and dumps into the Rio Negro, a major tributary of the Amazon. This phenomenon, river bifurcation, is incredibly rare on this scale. It means a fish could theoretically swim from the Caribbean coast all the way to the Atlantic, a journey connecting 2 separate continental drainage basins. For years, people thought it was a myth, but this 2-timing river is very real, proof of the planet's complex plumbing. A river splitting its loyalties is one thing, but what about a river that's a thief? This is a geological process called stream capture, or more dramatically, river piracy. It's when one river literally steals the water from another. It's a heist that takes thousands of years. Imagine 2 rivers in adjacent valleys. The one with more erosive power chews away at the land, its headwaters slowly eating backward into the ridge separating them. Eventually, it breaks through and intercepts the neighboring river. Suddenly, the weaker river finds a new, faster route to the sea and is permanently diverted. Its old, now dry channel is left behind as evidence of the crime, a feature geologists call a wind gap. From Grand Theft Hydro to the comically small. We've spent so much time with giants like the Nile,
But what about the other end of the spectrum? In Great Falls, Montana, lies a river so short it's almost a punchline.
The Roe River is the world's shortest, averaging a mere 201 feet long. That's just 61 meters. You could walk its entire length in under a minute. It's not a creek. It qualifies as a river due to its powerful flow from giant springs, which pumps out over 150 million gallons of water a day. The Roe River begins at the springs and ends just 201 feet later, flowing into the much larger Missouri River. Its entire existence is a brief moment of riverhood before being swallowed by a continental giant. A river's journey is supposed to end at the sea, right? But what happens when a river travels 1,000 miles and just stops? This is the mystery of the Okavango River in southern Africa.
It rises in Angola, flows through Namibia, and then, instead of aiming for an ocean, it pushes deep into the Kalahari Desert in Botswana. It never finds the sea. Instead, it creates one of the world's largest inland deltas, a 6,000 square mile wetland oasis teeming with wildlife in the middle of a desert. Where does all that water go?
About 96% of it either evaporates under the African sun or is used by plants. The rest just seeps into the desert sand. It's a river that sacrifices itself to create a paradise. From a river that vanishes into sand, we go to one that seems to spring from the underworld. Deep in the Peruvian Amazon is the Shanai Tempishka, the boiling river. For 4 miles, this river is lethally hot.
Temperatures can exceed 200 degrees Fahrenheit, or 93 Celsius, hot enough to brew tea, or, tragically, boil small animals that fall in. The puzzling part is why. There are no active volcanoes nearby. The leading theory is that water from the Andes seeps deep into the Earth, is heated by the planet's geothermal gradient, and then forced back to the surface through a fault line. It's a non-volcanic geothermal system of incredible scale, one of the Amazon's most formidable mysteries. Not all of nature's puzzles are natural. Sometimes the most mind-bending waterway reflects a puzzle of our own making. For this, we look at the Citarum River in Indonesia, though you might not even see the water. The Citarum is infamous as one of the world's most polluted rivers.
For stretches, its surface is a solid blanket of plastic, styrofoam, and industrial waste. The puzzle isn't geological, it's human. How does this happen? The river is a lifeline for millions, yet it's been treated as a sewer and landfill by factories and a dense population with poor waste infrastructure. The water is a toxic cocktail of lead and mercury. It's a heartbreaking example of a river pushed to the brink, a flowing monument to an environmental crisis. After that heavy reality, let's find a river that seems like a fantasy brought to life. In Colombia flows Caño Cristales, known as the River of 5 Colors or the Liquid Rainbow. For most of the year, it's an ordinary river. But for a brief period between the wet and dry seasons, something magical happens. A unique aquatic plant, Macarenia clavigera, blossoms in a riot of color. When the water level and sunlight are just right, the riverbed explodes into brilliant shades of red, pink, yellow, green, and blue. It's not the water that's colored, but these plants clinging to the rocks below the clear current. The spectacle turns the entire river into a flowing piece of surreal art. We've seen rivers that steal, boil, and vanish. Our final puzzle is perhaps the most mind-bending, because it's a river that shouldn't exist in a place we can't see. We're going beneath the ice of Antarctica. For decades, we pictured Antarctica as static and frozen. We now know that miles below the ice sheet is a hidden world of liquid water. There are hundreds of subglacial lakes, some enormous, all connected by vast flowing rivers. How? The immense pressure from the ice above lowers water's freezing point, and geothermal heat from the earth below keeps it liquid. Scientists have used radar to map these hidden waterways, a continent-spanning plumbing system cut off from the world for millions of years. It's a truly alien environment, raising the tantalizing question: if there are rivers, could there be life? Every river must meet its end, a final surrender to the sea where freshwater and saltwater embrace in a dizzying dance. But is it an end or a transformation? For us, this is that moment, the delta where our journey flows into a much larger ocean of knowledge. We've navigated the rapids of history, biology, and geology, and now we have just a few final, profound currents to explore. Let's make our final deep dive. We've seen how rivers give life, but they can also hold on to the ghosts of what they once were. In many parts of the world, climate change and human intervention are creating phantom rivers. These are riverbeds that only flow for a few weeks or months a year, or sometimes not at all. The formerly mighty Colorado River, for example, now so heavily diverted and overused, has often dried up completely before reaching its natural delta at the Gulf of California. For years at a time, its final 100 miles were just a cracked, saline puzzle of dry earth. This transformation reveals a sobering truth. A river's permanence is not guaranteed. Its pulse can weaken and its voice can fall silent, leaving behind only the memory of water etched into the land. But just as we can diminish a river, we can also bring one back from the brink. In one of the most ambitious ecological restoration projects ever undertaken, the Elwha River in Washington state was literally set free. For a century, two massive hydroelectric dams had choked the river, blocking salmon from their ancient spawning grounds and starving the coastline of essential sediment. Then, starting in 2011, both dams were systematically removed. The result was almost instantaneous. The river roared back to life, recarving its old channels. Sediment flowed downstream, rebuilding the delta and beaches. And most miraculously, salmon and steelhead, whose ancestors had been blocked for generations, returned to the upper reaches of the river, repopulating a watershed that had nearly forgotten them. It's a powerful testament that a river's story doesn't have to end in a ghost. It can have a resurrection. Our journey has been anchored to the rivers of Earth, but the concept of a flowing channel of liquid is not unique to our world. On Saturn's largest moon, Titan, it is so cold that water ice is as hard as rock and forms mountains. But it's not a dead world. Titan has rivers, lakes, and seas made not of water, but of liquid methane and ethane. The Cassini spacecraft mapped vast, branching river systems that are eerily similar to the Nile or the Amazon, complete with deltas, oxbow lakes, and canyons. These hydrocarbon rivers are carved by methane rain, flowing across the frozen landscape under a thick orange nitrogen sky. It's a staggering thought. The fundamental physics of fluid dynamics that shape our world are powerful enough to sculpt another, using elements we'd consider fuel as the lifeblood of its geology. Back on our own planet, the rivers we see today are often just the latest authors writing a long geological story. Many of the world's most spectacular landscapes were carved by rivers that no longer exist. Before the modern Colorado River began carving the Grand Canyon about 6 million years ago, other ancient, or paleo rivers, flowed through the region, some in completely different directions. Geologists find clues in misplaced river gravel and oddly oriented canyons, piecing together the stories of these lost waterways. It's like discovering the faint, erased pencil lines under a finished painting. These phantom rivers show us that the landscape is not a static canvas, but a dynamic one, constantly being scraped clean and redrawn by the patient, powerful artistry of flowing water over millions of years. Perhaps the most profound impact rivers have had is not on the land, but on our minds. For as long as humans have told stories,
Rivers have been central characters, serving as boundaries, sources of life, and metaphors for the journey of existence itself. In ancient Egyptian belief, the sky was a celestial river called Nut, which the sun god Ra sailed across each day.
For the Greeks, the river Styx was the formidable barrier between the world of the living and the underworld of the dead. In Hinduism, the Ganges is not just a river, but a sacred goddess, a destination for pilgrimage with the power to purify the soul. From the River Jordan to the Amazon, these bodies of water flow through our myths, our religions, and our art, proving that a river carves a path not just through rock, but through the very heart of human consciousness. This connection isn't just spiritual, it's deeply ecological in ways we're only just beginning to appreciate. An incredible ecological theory called the river continuum concept proposes that an entire river system, from the tiniest headwater streams to the broad, slow-moving mouth, can be viewed as a single, continuous, functioning organism. What happens in the small, shaded streams upstream directly dictates the type of life and energy available hundreds of miles downstream. The insects that shred leaves in the mountains provide the processed food for fish in the middle reaches, which in turn influence the filter feeders in the estuary. It reframes the river from a simple channel of water into a cohesive, living system where every part is interconnected like the organs of a body, all working together in a seamless, flowing process from source to sea. And this brings us to our final 100th fact, one that connects you, me, and every living thing to the river flowing past your town. The water itself is impossibly ancient. The very same H2O molecules that make up the Amazon, the Nile, or the tiny creek behind your house have been on an unending journey for billions of years. The water in a river today could have, in a past life, been inside a dinosaur. It could have been locked in a polar ice cap for 10,000 years, been part of a primordial ocean, or fallen as rain on the first flower to ever bloom. Every single drop is a traveler through time, part of a closed system that continuously cycles through evaporation, condensation, and precipitation. So when you stand on the bank of a river, you are not just looking at a feature of the landscape, you are witnessing a living, moving library of Earth's entire history, a current of liquid time that connects all eras, all continents, and all life in one continuous, enduring, and truly amazing story.